All right, guys, welcome to, this is 10.6, okay? Beautiful 10.6. Aren't you just excited about 10.6 and how much you've learned so far? This is 10.6, and we are almost done with chapter 10. Yes, we're zipping through 10.6, guys. Before we start this lesson, remember we did this problem on our whiteboards where I had you find the area of this this regular polygon. And this goes back to chapter 9 stuff that we did. I think it was like 9.2, I think it was. Or actually it was, yeah, 9.2. So if you do not remember this, 9.2 in your notes is a good starting point, okay? But just to kind of quickly review, because this is super important for this lesson, again, because we're going to use it again. Let me go over this real quickly. Remember to find the area of this thing. Number one, the area formula was area equals 1/2 the apothem times the perimeter. Remember, this was for the whole polygon. This is the area. Now to use this right here, I need to know what the apothem is. Remember the apothem? Excuse me, guys. Apothem is the point from the center to the edge that's perpendicular. You need to know what this is. Okay, well, to know what that is, well, I already know two things. I know that if I was to break up this hexagon into triangles, I know that each angle in here, like this, 1, 2, 3, 4, 5, 6, would be 60 degrees each, because six of them times 60 is 360 degrees. So I know that each one would be 60. But if I cut one of these 60s right here in half, then I know this is going to be 30. And if that's 30, then I know that this is 90, and I know this one's going to be 60. Remember that magical triangle again? This is just review, because we did this in class already. Oh, wrong way. Remember that magical triangle that I told you need to remember? Even I memorized it already. 60, 90, 30, 60, 90, remember that? Remember how I told you that this bottom one's always x? And what is the hypotenuse here? Hypotenuse is always a 2x. And then the apothem here, or the height, would be x times what? X times rad 3. Okay, so you need to remember that. So if my bottom part is a 6, because that's what this is, half a 6, if the bottom is a 6, then what's going to be the height? The height is going to be a 6 rad 3. Okay, so then this one would be 6 rad 3. Am I? Yeah. Okay, so if that's 6 rad 3, then you can find the area, because then all you got to do is take this. That's your apothem, right? That number is going to go right there. And then you know what the perimeter is, right? The perimeter is the whole thing, so that's 12, 12, 12, 12, 12, 12. That's 6 times 12. 6 times 12 is 72. So then I got to do is plug it in. 1/2 times 6 rad 3 times 72. Well, I'm going to do half of 72. What's half of 72? That's going to be 36. So I'm going to do half of 72 is 36 times, oh, hold on, that's confusing me. 6 times 6 rad 3. Then I multiply the 6 and the 36. Oh, goodness, here you go. One more time. 36, 6. That's going to be 6 times 6 is 36, 18, 19, 20, 21, 216. So this ends up being 216 rad 3 for the area, okay, of this shape. That's the answer. Okay, we're going to need to remember how to use this, okay? So make sure you remember it. If you don't, again, look in 9.2. That's where it was in your lesson. Okay, so you should have notes that I gave you for this lesson. It's going to be super easy, I guarantee you. You will like this lesson because it's really easy, and it's quick. I'm going to try and get this done in about 15 minutes. Okay, if you don't have the notes because you were absent, then, try your best to copy down these shapes. So we're going to talk about volume of prisms and cylinders. Well, what's the difference between volume and surface area? Well, there's actually a really neat video, which at the end I'm going to show you. Actually, you know what? I probably have time right now. Do you guys see this? Hopefully you can see this. Really funny. Little third graders, I think, or second graders. Oh my goodness. Oh my goodness, Mr. Prola, you are not showing this. Oh my gosh, hold on. Let me advance. This is ridiculous. There you go. Did you guys catch that? Volume on the inside, surface on the outside. Oh my gosh, how catchy is that? So volume is about all the stuff that makes up the shape, the inside parts, okay? So we're going to talk about is first the formula. What formula do you use? Now I can guarantee you that everyone probably knows the formula for the volume of the prism. Like this one right here, the volume of the first one right here. I hope you all know that basically, even if it's a perfect cube or if it's a rectangle, I hope you know what it is. Let me actually bring down my hand, I'm sorry. So whether it's a perfect cube or a rectangle, it's always going to be length times width times height, right? Length times width times height. So even if it says SSS, well, if it's a perfect cube, all you got to do is multiply it 3 times the same number. But length times width times height. Okay. What about the surface area for something that doesn't really look like a nice perfect rectangular cube, like this? Let me put this in the front, guys. Well, there's no length times width times height here, but there's a different shape on the bottom. So whenever you get these type of different shapes like this prism, this is a triangular prism, then that just means you got to first find the area of the triangle and then multiply by the height. So the formula is going to be really simple one. All it is volume is going to be the base times the height. But I want the area of this, right? The area of the base. So if it's a triangle, then you got to find the area of the triangle first and then multiply by the height. If it's a hexagon, then you got to find the area of the hexagon first and then multiply by the height. Okay? So it always depends on what shape is on the top and the bottom, okay? But all you need to do is find out one of them and then multiply by how tall it is, and you're done. Now, there's this guy, and his name was Cavalieri. Cavalieri, I'm going to call him. Cavalieri, really fancy guy, there he is. Cavalieri said that, imagine this is a really neat way to show it. This stack of CDs, this thing has the same volume as if you were to shift it, right? If you were to tilt it, kind of shift all the CDs to one side, it's still the same number of CDs. They were just tilted to the side, and now it just kind of looks like it's, you know, sloppy, but that's fine. This thing is still the same volume as the one over here on this side, even though it's tilted. Because if I was to push it back in place, you know, and push it this way, oh, that's weird, huh? And push it that way, then it'd be the same exact volume. So if this one, for example, if this is 4 times 2 times 10, and that's going to be 80, okay? Then this one's still going to be the same thing. 4 times 2 for the width, and then how tall it is? Well, I don't measure it this way, right? That's weird. You don't measure someone slanted. So here you measure the height. The height is straight up, and the height is still going to be 10. So this is still going to be 80. So Cavalieri said that even if you tilt something or slant it, it's still the same volume. Okay, that's super important here. So that's why it doesn't matter whether it's this one or this one. They're the same exact volume. Okay, even if they're slanted. Let's go ahead and do one of these right here real quick. Find the volume of this cube. Oh, not cube, it's a rectangular prism, right? So this one's pretty easy. Obviously, volume is length times width times height. You know this, guys. This is from like elementary school. 13 times 3 times 5. So that's going to be what? 39. Hold on, we'll write it out. 39 times 5. Oh, what's that? You know what? I should have a calculator out here just so I can go a little faster. 39 times 5 in my head, because I'm really good at these, is 195. Centimeters, it's not squared, right? What are these guys? Cubed. Okay. All right, that one's done. Told you this was easy. Oh, but this one's not easy, right? Why is this one not easy? Okay, this one is not easy because look at what kind of shape you have on the bottom. This is a hexagon. I told you you're going to have one of these. So you got to find out here for this one. This is going to be, the volume is going to be the base times the height. Okay, well, I need to know what the base is. And this is a hexagon, so guess what you're going to do? You're going to find out what the apothem is. You're going to find out what the height, okay, all this stuff. So you know that this is 10 on the bottom, so I'm going to break it up into 5. And there's my triangle. I know this is going to be a 90, because this is a hexagon. Remember, it's 60-degree angles all the way around. That means that this is 30, and this is 60. Again, if you don't remember this, look at the first problem that I showed you at the very beginning of this lesson. I'm just doing it all over again. Except the difference here, this one is a 5. And so if this is a 5, what's that going to have to be? Hopefully you said that that's going to be 5 rad 3. You need that. Okay. And what's the area of the space then? Do you remember the formula that I just showed you also from the beginning? If not, then you need to go back and rewatch the video. Area equals 1/2 the apothem times the perimeter. What's the perimeter here? Well, if the whole thing, if each side here is 10, 10, 20, 30, 40, 50, 60. So I'm going to have 1/2 times 5 rad 3 times 60. Okay, let's figure out this. What's half of 60? I like to do the big number with a half. That's 30 times 5 rad 3. 30 times 5, 150 rad 3. Okay, that's the answer. But that's just the base, right? So I found out what the base was. The base is going to be 150 rad 3. And now times, what's the height? How tall is it? 12. So you're going to do 150 times 12. I'm going to do it for you guys, even though you should be doing it, obviously. 1800 rad 3. Okay, you can leave it like that. I don't mind if you leave it like this. Feet cubed. That's perfectly okay. If you wanted to work it out, you could use your calculator and figure out what rad 3 was times 1800, and that would give you a better answer, okay? And that's it. Good job. Wowzers. You guys are doing amazing. Look, I mean, thumbs up. Yay! Thumbs up. Oh, snap, Mr. Puebla. It's the first time I see you in a video, and why do you look so orange? I don't look orange. That's tan. Tan, guys. Tan. Good job. Good job. All right, next one. Wow, I caught some of you guys off guard, huh? You're probably rewinding right now. Oh, my goodness. All right, volume of cylinders. So we're done with prisms. Let's look at the cylinders now. The volume of a cylinder, well, it's kind of like the last one, okay? The volume of a cylinder is going to be base times height. Same thing, except what's the base here? And hopefully you know, you're looking at this, you're saying, well, the base here is a circle. The base here is a circle too. So really, you can write this a little bit differently if you want. There's two ways to write the formula. As long as you know it, the volume is the base, which is, I know what the base is. There is pi r squared times how tall it is. Okay, pretty simple. Now, why is it that, these things I need to keep putting these forward. Why is it that this one is going to be the same as this one? Same volume. Why do you think so? Remember that guy's name? Remember? This guy, Cavalieri? Well, guess what? Imagine a stack of CDs. A stack of CDs right here that has a radius of 8 and a height of 10. This thing's going to have the same exact volume as even something that looks like this, all weird and crooked and, you know, curvy. This thing is still, even though it looks like this, really weird, it's still the same height, same radius, same 8. You're going to have the same exact answer, okay? So Cavalieri discovered this. He just basically put it on paper and said, look, now I'm famous. So let's go back to that. Okay, so we got that down. Basically, we said base times height. That's all it is. So let's go ahead and practice one. Pretty simple. Volume equals the base. Okay, well, the base is the pi r squared, okay? Base times height. Well, my base is pi r squared. Pi r is, oh, don't put 18. That's the diameter. What's the radius? 9 squared times how tall it is? 14. 9 times 9 is 81. 81 pi times 14. What's 81 times 14? 81 times 14. It's going to be a big number, isn't it? 1134 pi. This is inches cubed. Now you could multiply pi 3.14 times that, and you can get a bigger number. Obviously, you can get, it's going to be around 3,560.76 inches cubed. Okay, I'll take either one. Usually a book will tell you when to use a pi. If it tells you to use 3.14, then they'll let you know. Okay, good job, guys. Good job. Awesome. Let's move on. Last one. I only gave you 2 problems, right? Okay, find the volume of this. I think I'm missing a number there, aren't I? You know what? For the sake of simplicity, let's make this 10 inches. All right, just practice this for me. Go ahead if you can, do it on your own. And then when you're ready, hit play and so you can see the answer, okay? I trust you because I know you're going to do this on your own. All right, so hopefully you got your answer. Now you're going to check it. Pi r squared, let's see, I got 24 squared times the height, 10. I made an easy number. I made 10 for you, okay? So no complaining. 24 times 24 is 576. So pi, 576 pi times 10. And then times that by 10, and then I'm at 5,760 pi inches cubed. That's your answer, unless you went one step further and you got really fancy and smancy, and you multiply it by 3.14. Then you did that. And you got 18,086.4. Okay? Guys, that's it. Literally. Heck yeah. Good job, man. Good job. Good job. There you go. Mr. Polo gives you thumbs up, guys. Thumbs up. You guys get thumbs up for this. Thank you so much for taking the time to finish both lessons. Guess what? We're practically done here. I just have one last thing. Lastly, I must ask you a question. Yes, just for the sake of making you guys smile and laugh. This was me at Hobie this past summer, helping out some seniors and juniors in high school. And yes, mustaches are cool. Lastly, I must ask you a question. What does it say? Let me see. This was an easy lesson, wasn't it? Have a great weekend, okay? Hopefully you guys had a really easy time with this lesson. We only have, I believe we have 10.7 and 10.8 left. Okay, so we'll probably be done with all of chapter 10 by Friday of next week, okay? I promise I'll be there every single day next week, so we would not be too stressed out, okay? Have a great weekend, guys. That's about it. From this, Puebla is signing out. Adios.